Hi everyone, welcome to the design and code review session of Stratos cluster monitoring improvement. I'm Rajkumar. I'm working as a software engineer at WSO2. So in this session, we can review the changes that I have done to the current cluster monitor hierarchy to allow any entity cluster monitors to be plugged in. So let's look at the current cluster monitor hierarchy that we are having now. So as you know, when a user subscribes to a cartridge, we are creating a clusters. So on cluster created event, we are creating and starting cluster monitors. So each clusters will have associated cluster monitor. It's a one-to-one mapping. But if you look at the current cluster monitor hierarchy, we are having an abstract monitor, which is an abstract class. Then we have a two subclass cluster monitor for monitoring service clusters, and we have an LB cluster monitor for monitoring LB cluster. But this abstract monitor is not abstract enough to be to allow any entity cluster monitor to be plugged in. For example, Docker cluster monitor. We can't plug in Docker cluster monitor here. The reason is this abstract monitor is based on network partition context and deployment policies and auto-scaling policies. But in Docker scenario, we don't have any network partition context. We only have auto-scaling policy. And we are using Kubernetes. And also these name are these classes names are very confusing, and if the number of cluster monitors are increasing, currently it is increasing, then these names would becomes more worse. I mean, we can't understand anything from these names because we have an abstract monitor here and we are having a cluster monitor as a subclass, which doesn't make any sense because I am proposing this structure. So this allows any entity cluster monitors to be plugged into this hierarchy, and I'm also changing the names. So you can see, so I have a root super abstract class, abstract cluster monitor. Then I have two subclass, VM cluster monitor for monitoring VM clusters, and I have a container cluster monitor for monitoring container clusters. So the concrete classes I have named according to this. Can you hear me?
Yeah, Raj, we can hear you.
Okay. So I have named according to this. A cluster can either be a VM cluster or Docker cluster, and that cluster can either be a LB cluster or service cluster. So service cluster means PHP or MySQL cluster, and we have LB cluster. So the concrete classes names are VM LB cluster, then VM service cluster, then Docker LB cluster, then Docker service cluster. So if we look into more detail, now in the abstract cluster monitor, we have cluster ID, service ID, and status of the cluster, then the monitor interval, how often we are going to monitor the cluster. And the rules related properties are come here because we are going to every clusters. Then in the VM cluster monitor, which is also an abstract class, the abstract cluster monitor is also an abstract class. So in the VM cluster monitor, we are having deployment policy, auto-scaling policy, and network partition context. So it is common to all VM clusters. Then we have a VM-LB cluster monitor as a concrete class that will monitor VM-LB cluster. Then VM service cluster monitor. So it is same for the containers case also. In container cluster monitor abstract class, I'm having a Kubernetes cluster context. So that is a Docker cluster context. It will have so it will hold the runtime information about a Docker cluster. How many minimum replicas, how many maximum replicas, like that. So let's move into the code. So I will share my IDE. Can you all see my Eclipse?
Yes, Raj, we can see.
Yeah, okay. So I have so this is the super abstract class, abstract cluster monitor, which is a thread, it's implement runnable. And here, as mentioned in the class diagram, it has cluster ID, service ID, and I have introduced this cluster type attribute additionally. So this cluster type is an enum. It can either be a VM service cluster, VM LB cluster, Docker service cluster, or Docker LB cluster. So when we receive an event, then if we retrieve the monitor from the map, then we can easily identify whether this monitor is monitoring a VM service cluster or Docker service cluster. So we don't have to get the cluster object from topology and get the cluster type from there. So since our monitor holds the cluster type itself, it is fast. And these attributes were already there, but these are extracted and moved into the abstract cluster monitor. Okay, so these four are related to rules, and this is destroyed says whether the cluster is destroyed or not, cluster monitor. And we have an auto scale rule evaluator, and we have a read configuration method here. These methods we already had there, but I moved here. So read configuration will read time interval, the monitoring time interval, and assign it to the variable. So I made this as an uh, abstract method. So each cluster monitor can have different time interval now because they can override. And this monitor method to monitor the cluster, and destroy method to destroy the cluster monitor. So this is the abstract cluster monitor. And if we go to the next abstract class, VM cluster monitor. So here the VM cluster monitor holds the map of network partition context and deployment policy, autoscale policy. It was already there. And earlier we used to assign everything within the concrete class constructor. But now we are calling super construct. I mean, we are calling super constructor and assign the relevant variable there, and we are assigning the rest of the the variable related to this class only here. And every other methods were already there. And if you see the VM service cluster monitor, here we only have the LB reference type and the hash primary attribute. Here also, so earlier we used to assign everything from here, but here we are calling the super constructor, and additionally we are calling the read configuration from here. So we have implemented the run method here and the monitor method here. So each cluster can have different monitor behavior, different monitor method, different behavior, and this read configurations. So we can, as you can see, we can read different different. So each cluster monitor can have different monitor interval, because in Docker case we are going to have very small amount of monitoring interval, because it will be activated very fast. Then each will have their own destroy method. Then this is same for everything. If we are looking at a VM LB cluster monitor, then they have their own monitor method. Then they can read. Currently I'm reading the same interval, but if you want, we can override this. And if you go to the container cluster monitor, that is then the abstract class extend, which is extending the abstract cluster monitor. There we are having Kubernetes cluster context and only the auto scaling policy. It doesn't have deployment policy. And in the Kubernetes cluster context, we are keeping runtime information of the Kubernetes cluster, like Kubernetes cluster ID and min replicas, max replicas, and current replicas, and expiry time, and so on. So we will review this Kubernetes cluster monitoring in a separate session. And next, the cluster monitor factory. Earlier we didn't have factory pattern, so now we have a cluster monitor factory. You just pass the cluster object and get the relevant get the relevant cluster monitor. You don't have to do anything from where you are calling. So it has a uh, get monitor method which returns an abstract cluster monitor, type of abstract cluster monitor. So if the cluster is Kubernetes cluster, we are returning the Docker service cluster monitor. If it is a LB cluster, we are returning VM LB cluster. Otherwise, we are returning that is a default one. We are returning VM service cluster monitor. So these two methods was already there, but we just moved into the factory method, factory class, and we are calling from the get monitor method. Okay, and the get VM LB cluster method was already there, and this is the new method, get Docker service cluster monitor. So if it is a class, if cluster is null, you are passing cluster object, right? So if cluster is null, we are returning null. Then we are getting the auto scale policy name that will come with the cluster itself. Then we are retrieving the auto scale policy. Then we are retrieving the Kubernetes cluster ID from the property. So this property will be set on the cluster created event. Then we are creating a Docker cluster monitor by passing this Kubernetes cluster context and cluster ID and service name and policy. Then we are setting the status of the Docker cluster as cluster created. Then if it has a reference to LB, and we are setting the LB reference also, but now we are going to support only VMLB. So that's about the cluster monitor factory. Now we can move to autoscaler context. So in autoscaler context, if you have the master branch code, you can just go through it now. We used to have three lists here, three or whatever the number of cluster list here, because uh, we had a map of cluster monitors, map of LB cluster monitors, and map of Docker cluster monitors. But since we are having the hierarchy now, we can have only one map string and the abstract cluster monitor, and we can store all the cluster monitors here. And the cluster monitor object itself has the clue whether it is a Docker cluster monitor or the VM cluster monitor, because it has a cluster type attribute. So here I have removed the other two map here and made this as one map.
Hi, Raj.
Yeah.
Yeah. Can you go to that factory class? I could see that you were using the reference, right? The cluster object itself. Why can't we use the cluster ID or something to get the cluster monitor? Because since
Here,
it is, yeah.
so I'm talking about I'm expecting a parameter of cluster object. So you are going to
Yeah,
pass
why
cluster
are you
ID.
taking the cluster object?
Okay, so you are going to pass a cluster ID, and I'm getting the cluster ID from topology and.
So how are you retrieving this? Sorry, I missed some points in the video. Can you go inside that get Docker service cluster monitor?
Okay. Can you see the code?
Okay, so you are creating the cluster monitor from here itself, right?
Yeah.
Ah, okay, okay. I thought you were just getting it. Okay.
No. So others have only access to this method, get monitor method. Every other
Okay.
method are private. So from the get monitor method, we are calling this private method. So you will pass a cluster object and get the cluster monitor. So you will call only this method, get
Okay,
monitor method.
then fine. Okay.
And so in this autoscaler context, I have removed all the maps. So and we are keeping only one map here.
Okay, that's great. Okay. And I could see that one of your enum was not having the header. I think the enum that you generated, or as I'm not sure whether it was not shown in the display.
Cluster.
Type.
Yeah. Yeah.
It's not there.
What you are asking for it?
Yeah, license header, you have to include it in all the classes, right?
License header.
Yeah,
Ah, right. Okay, I missed. Sorry.
maybe you can make it automatically generated or like you'll have to manually
No,
add
no,
it.
I have added. I'm adding it manually, so yeah, I can add it. That.
Okay,
Okay.
okay, thanks, sir. You can go.
Raj,
Yeah.
Hello.
Raj,
Yes.
to hold on a second. Raj, to
Yeah.
sorry, I'm going. Hold on. Yeah, Raj, to add some points to the the things that Rekha mentioned in the cluster type, right? In the enum.
Yeah.
So the I think the best way to add the license header is to configure your IDE
Ah, okay.
so that each time you create a new Java class
It will
or
automatically.
a new file, you will add the license header automatically, so that you would not forget to add that.
Yeah.
You can configure the IDE like that, and also in the num class, better to add a class comment
Ah,
mentioning what meant by the cluster type or something like that.
mm.
Uh,
Yeah, I will do that also.
Also in the autoscaler context,
Okay.
so in this map, the cluster monitors map, right?
Yeah.
Okay, so the key of the map is the cluster ID.
Yeah.
Okay. Uh, yeah, you have mentioned it in the command, but it will be more clear if you specify that key equals this and the value equals this, something like that,
Ah,
within a comment, so then it's kind of clear.
right. Okay.
Just my opinion on that. So uh, yeah, you can carry on.
Okay. And then we will go to the topology event receiver of autoscaler, and we will review what we have changed here. So if so from topology event receiver on completed topology event, we are starting the cluster monitor, right? So earlier what we had here is three if condition. If the cluster is LB, then add we will check whether the LB cluster monitor is in the LB cluster map, because we had three map there, right? So we will check whether the LB cluster was is there in the LB map. If it is not there, then we will create an add. Then in the second if condition, we will check whether this is a Kubernetes cluster. If it is a Kubernetes cluster, then we are checking the Kubernetes map. But now we have improved it to like having one if the monitor is not there, we will create an edit. That's it. Uh, so this cluster monitor adder also. So earlier we had three cluster monitor adder. For one for LB cluster monitor, one for just default cluster monitor, and one for Docker cluster monitor. But every cluster monitor adder is doing the same thing. It's creating a monitor and starting it. So now we have a hierarchy. So we can uh, and we have the factory implemented. So we can use this use a single cluster monitor adder. So it has a cluster object.
Raj,
Yeah.
can you go to the complete topology event listener part?
Yes.
So here you are using the complete topology event, and
Yeah.
you are using it every time, right? Because CC is publishing the complete topology event every 30 seconds.
Yeah,
So this your listener is getting triggered
yeah,
every time, but
yeah.
this complete topology event is meant to be used as a first time thing in your initialization process or as a recovery mechanism. So I think we'll have to rethink the logic here, because
But,
it should be
but
used once, in my opinion,
yeah,
and
but
you should handle it from individual events in other cases. So it should be used only as an initialization or recovery mechanism.
okay. It was already there, so I didn't think about that.
So Raj, I think when you refactor, you have missed that logic. So earlier, as far as I know, as Attila said, the complete topology event listener should only be like used to initialize the system, initialize the topology, and then on that point onwards, you need to build the topology using the events that you would receive. So that's the Stratos topology event model. So
But
so
yeah,
in yeah
okay. So I'm
yeah
pretty sure that
okay. Let's chat, but I'm also kind of since like this particular code is like was being used like from
yeah,
Stratos 4.0, so and we never faced the issue, so probably
yeah. Even though we are
I don't
starting,
know. Let's see about that. Probably when we evaluate your PR, we could notice that.
okay.
I think
If,
Raj,
yeah.
I think you mentioned that the logic was there, right?
Which logic?
To avoid executing this after first time.
No,
I heard like that. No, it was not there.
yeah, it was not there.
All right, okay. I
But
heard like that.
but
Okay.
the start cluster monitor will be executed only if the cluster monitor is not there. So in the second I mean, if we get this event again,
Okay.
then the cluster monitor will be there. So this method will not be executed. I mean,
I
here.
see. Okay, I think we have to find a mechanism to execute this only at the startup. Or basically, we have, I think, in the topology, we have whether it is initialized or not. So we can check that and execute this.
All right.
Yeah, I think
Um,
that's what we did.
yeah, it's not the case because the initialize, even though the topology is initialized or not, we are triggering these listeners regardless of the initialization. So we won't be able to check that state because before you trigger this particular listener, the topology is actually available. So we need to either fix it at the messaging component level or make it fix it in the autoscaler level. We have to decide on that.
Rekha, I think we had that because we were able to check topology is initialized or not, right? Didn't we?
Yeah, we do have a method to check whether topology is initialized,
Yeah.
but the problem is this complete topology event listener is triggered every time the complete topology is received.
Yeah, that's correct. But the issue is like we just have to have the if condition to check that, right? Isn't it?
Uh, so Lyra, I think the topology is already been initialized by the
Yeah.
managing, the whole cluster, right? So I'm also like in line with Rekha. I don't think we can check that and decide this. But we have done this same logic in other components like Stratos Manager
Yeah. Okay.
and
Okay.
cloud
I see.
controller. So I
Uh,
think we have to just like listen only for once and then skip
Yeah.
the
Maybe we have handled
event
that
somehow.
in other component, and we can do the same thing here.
Yeah.
Okay. Fine. Go ahead.
just to add just to add something,
Yeah.
I have noticed that in Stratos Manager also we are listening to this complete topology every time. But if you look at the cartridge agent code, you can see that we are keeping a separate variable to check whether the complete topology is initialized. So once we initialize, so once the first event is received, we are setting that to true. So if we have received this complete topology earlier, then we are not executing that logic again. So we can do something like that.
Okay. Okay, I will carry on. So this is the second event, member ready to shut down event. Here in Docker scenario, we don't have to do anything, but I have prefactored something here. Earlier we used to check whether the Docker, whether the LB cluster monitor exists. Then from that only we identified, okay, it is an LB cluster. Or then in the else if condition we put whether the default cluster monitor exists. Then we decide, okay, this is a cluster monitor. But since we are having only one list now, I have reduced it to one if else. So we are returning the LB, but so sorry, we are returning the monitor, but this monitor has a clue whether it is monitoring the VM service cluster or LB cluster because it has a cluster type. So I'm putting the if condition here. If the cluster it is monitoring is VM service cluster or VM LB cluster, we are doing these steps. We are getting network partition context, and we are terminating. We are getting the network partition context. From that, we are getting the partition context. Then we are getting the we are terminating this, and from the partition context, we are moving the member from the active member. But in Docker scenario, we don't have to do this because we have decided last time we don't have to do anything in the member ready to shut down or member fault events. Then in cluster created event, it is same as completed topology event. We are calling the start cluster monitor method. There we are checking whether the monitor is already exists. If it exists, we don't do nothing. If it is not existing, we are creating a new cluster monitor by using this.
Raj, can you go to that section where we check for the cluster type, cluster monitor type?
Yeah.
Yeah, what is that VMLB? Is that a constant cluster type VMLB cluster and VM service
No,
cluster?
this is the enum.
That's the enum. No, all right. Okay. Okay, please go ahead.
Why is that a problem?
I don't see a direct problem. Can others comment on that?
Is there any problem with using enum like this? Or
Uh, s- so
I
are you
think it would,
comparing? Yeah, go.
I think it would be better to use equals method than using this equals sign for comparing strings.
not as
Can you all agree
yeah.
on that, or like, is it fine to use equals sign?
But since this is an enum, it's an integer check, right? But I'm not sure the best approach to check with enum. I think we'll have to do some bit research on that.
Probably we have to get that. We have to convert to two string. Enum has two string, right?
Enum has a name to string.
And
Yeah.
then trump equal the string. So what's the type of get cluster type? Like
Sorry.
what's the type of the monitor dot, like what does monitor dot get cluster type returns? Is it
Yeah,
enum?
whether it's monitoring.
Is
Yeah,
it a
it's returning enum. Yeah.
then enum? Okay.
Yeah.
Yeah, I think
It's returning enum.
So as far as I know, using the equal sign is okay for enums.
I also googled it and
Yeah,
there
because
is
it is just an integer check as others mentioned. So I think this method is okay.
Yeah, if both are enums, that's fine. I think. Yeah.
Yeah, I think yeah, I have just googled a bit on Stack Overflow. It says the equals good.
You mean equals method or equal sign?
No, equal sign. This what you have used
Ah,
is correct.
okay,
I have posted the link in chat. Maybe you can see.
okay, thanks.
Okay,
Thanks.
that's it.
So then, if the cluster is VM service or VMLB, we are doing this stuff. If it is Docker service cluster, we are doing nothing, as I have already mentioned. We don't have
And
to do this check, but I'm just
okay, that's one another thing. Have you set any like column length in your ID? I could see your sentence is going beyond some length. So it's always better to use some kind of like length as we agreed upon in the mail, 100 or
yeah,
120. I can't exactly remember. So
yeah,
if you split up the line accordingly, then it will be like more good for the users to read it.
yeah. Okay, okay, I will do that
I
also.
think you can set it somehow. I'm not sure about Eclipse. You are using
But
Eclipse,
Isuru,
right?
but Isuru is going to send a for template,
Yeah, then,
so
yeah.
I
Then
told
if
to
you
do
follow that up, that's
just the same one. Yeah. And in cluster created event, we are just calling start cluster monitor. Then from, as I have already explained, from there, if the monitor is already not there, we are creating the monitor. If not, just we are doing nothing. So in this cluster monitor adder class, we are treat so this is so this was already there, but instead of having three cluster monitor, we are just having one now because we are using cluster monitor factory here. So we are passing the cluster object and get the monitor, but this is type of abstract cluster monitor. That's fine. So we are putting into the list then. If you go to the next cluster maintenance mode event, this is also already there, but there we had a 3 if condition to check whether the cluster monitor is existing in 3 different maps and set the cluster accordingly, the cluster status accordingly. But we are with one if else we are setting the status here. And on cluster removed event, um, again we are using only one line of code to remove the cluster monitor. And on member started event, we are not doing nothing. And in the member terminated event also, this is same as the member to shut down and the other events. For the VM service cluster and VMLB cluster only, we are interested in this event. And for the Docker service cluster, we are not doing anything.
And Raj, there's another small suggestion for the variables which are you used internally in each of these listeners. If you could give some meaningful name for that event, that would be better as I guess, because it's
Uh,
using E, right? All the same.
yeah,
Yeah, if you like change it to whatever the relevant event
yeah,
name.
cluster, yeah, that would be good. Okay.
Yeah.
And in every other event listeners, we are doing the same thing. In member activated event also, we are doing the same thing. In member ready to shut down event also, we are not caring about for Docker scenario. For the member maintenance event also same. And this is about the topology event receiver. And let's look at the health state event receiver.
Raj,
Yeah,
could you please again go to that previous event receivers that you like listed down? Now this like if the we are like doing different stuff based on the uh, cluster type of the monitor, is it?
yeah,
So we have some if else conditions for that. maybe would it? I don't know. I'm not very thorough with this piece of code, but do you think it's better if we define an abstraction there as well to stop using the if else conditions?
No, I think no, because so these codes are purely based on network partition context, right? Inside if condition, we are getting network partition context for VM clusters, because VM clusters are based on network partition context. But in Docker scenario, this is Kubernetes cluster context. But I don't think we can make those in one hierarchy, Kubernetes cluster context and network partition context in one hierarchy. Then only we can.
You mean it's not possible or it's difficult to get define an abstract cluster context class which will like be the parent of this Kubernetes and uh, the other cluster context, is it?
Yeah, I don't think we can make them in one hierarchy, because
Okay.
I mean we can't abstract anything there, right? This has network partition ID, and that one is having Kubernetes cluster ID.
Okay, no,
And
what I mean is like that would be much nicer code if you can do that. But of course, if it's unfeasible, that's fine. Thanks. You can go ahead.
okay,
But
we
Raj,
will.
I'm completely agreeing with what Isuru mentioned. So I can see some pattern here. So we are checking the type and we are executing a certain logic. So why can't we move this logic into the relevant, mm, concrete cluster monitor class and have some kind of a polymorphism behavior? No, I'm not completely sure whether it's doable, but I can see a pattern. Just my opinion.
Yes, Akhil, as Raja explained now, it's like in this cluster monitor VM cluster type and this Docker service cluster type, like the data are so much different that it's like difficult to get them to abstract out the parent class. That is what the reason he mentioned. I too am not sure about not thorough with this code, but maybe he has point. If he can do that, that would be like the best way would be to define a hierarchy and then use polymorphism. Yes.
But then again, that information is already there in the concrete cluster monitor class, right? For example, in Docker cluster monitor, we have uh, the host ID, Kubernetes group ID, and all that information. Am
Yeah,
I correct?
yeah.
So then, I think you have all the necessary elements to execute that logic.
Mm,
Yeah, it seems I also can agree with Akila. Here, what you are doing is you are moving this active member to termination pending members, right?
yeah.
So I think we can add like a method that VM cluster monitor abstract class, because those both of those are VM abstract class, right?
Yeah.
So the method could be in the VM abstract cluster monitor, right?
Okay.
Yeah, it seems so. So just have a look at whether we can do the improvement. And
Yeah.
Yeah, Lahir, so you're saying
yeah,
that we can have that method in the abstract class and then we can
yeah.
override that in the relevant concrete classes, right?
Uh, do we need to? Oh, yeah, yeah. So this is VM
Because
cluster.
Docker service cluster and VM service cluster is like those are different hierarchies, right?
No, no.
That
VM both are in
it's the
one
same.
under one abstract VM cluster, right?
They are in the same tree, right?
Yeah, yeah. Same tree, and they are in the same secondary level of abstract class. I mean, secondary level means the first one is the highest of the tree, and the second level is VM abstract monitor, cluster monitor, and container abstract cluster. It looks like that. I'm not sure. As Akila member, Akila also told, just try that out.
Okay, I also now feel that we can do
Yeah,
that.
yeah. Also, Raj, at the end of the that logic, you are checking the uh,
Yeah, here.
Docker cluster, right? So
Yeah,
this logic can be removed, right? This is
yeah. But
unnecessary
yeah,
question.
currently we don't have nothing to do here. But maybe we might have something to do here.
Okay. So
That's why
I
we
mean,
yeah
have
we
we
can.
ID? I mean, is it not done yet? Or we have identified for this release, we don't have to do anything.
Yeah. If this we can remove this.
So yeah, for this release, please remove this. Yes.
Yeah. Okay.
Yeah. Okay. Cool. Thank you.
Do we need to remove this? I think like keeping this like improves the readability of the code, right? That saying that we don't have to do anything specific for this case,
Yeah, but
isn't
this
it?
else would be executed and is unnecessary, right?
But there's nothing in that, right?
Yeah, but there's a cost. There should be a cost for these sales.
Um,
Okay. In that case, we will remove it for this release.
okay, fine.
Yeah.
Use
Thank
the
you.
best wages.
And in the autoscaler health event receiver, um, health stat event receiver. Again, this I think this can be done like Akila said. Uh, I'm having two applications here to check whether this is VM cluster or the Docker cluster. If it is a VM cluster, I am setting the load average in the network part of the context. If it is a Docker service cluster, I am setting the average load average in the Kubernetes cluster context. So we can have the same method in the abstract class, and we can try to override that. That will
Yes,
simplify the
yes,
logic.
yes. That would be better, Rajesh.
Yeah. And in average memory consumption vendor also we are doing the same thing. If it is VM, we are setting in the network partition context, and if it is Docker, we are setting in the Kubernetes context. And in every other event, we are doing the same thing. Do you want me to go through each event?
So Raj, for the each event you need to abstract out the logic, right?
Yeah.
You need to find like meaningful names for the methods that you're uh, gonna implement.
Yeah.
And in that way, that's a good suggestion to abstract it out. Otherwise, you have the same logic duplicated in each of these methods. So if you run Zona with your code, it will like complain you that you have duplicates, so many duplicates. So like even if you say like more than five,
But
number
this,
of lines are got duplicated across all the methods. So if you are going to abstract it out, then you don't need to worry about that because it goes into the abstraction.
okay, but if we I have one concern. If we abstracting out, we are calling that method here, right? Say this point we are calling that method. But what if we don't want to call that method for one particular cluster? Because in the autoscaler topology event receiver, we had a situation like here we don't have to do anything, but here we have to do something. So if we abstracting out and calling the method here, so
So the implementation should be at the concrete class, not the
so
abstract
we
class.
are not doing in the overridden class, overridden
Yeah,
method.
it should be overridden in the complete class, and that should not do anything. Yes.
And Raj, basically in at least for this logic,
Yeah,
uh, both these VM service cluster and VM LB cluster are inheriting the VM abstract cluster, right?
yeah,
So there we don't have to implement the methods in child classes because
yeah,
the logic is same, right?
Yeah, we can have the default implementation there if we need
Yeah,
additional.
exactly, yes, great. Okay.
Then in the member consumption, so we are doing the same thing, but we had abstracted out. So this is same for every event here.
Yes, Raja, I don't think you need to go through each and everything. Now we know what to improve, so we can work on that.
Yeah, okay. And I have some other. In autos, till only we earlier had these methods: get cluster monitor and get LB cluster monitor and get Docker cluster monitor. Since I have moved these methods inside the factory inside the factory class. So I have just commented out this, but I can remove this everything. We don't need this anymore.
And Raj, one another point, can you see this get cluster monitor? It has that nice Java command style. So if you could generate like that the comments to most of those methods, that would be great because others can identify it from that what it is doing and what it is returning and everything. Like
Yeah,
you
okay.
can even generate docs later.
Yeah, it was there, but
But I saw like some other methods what you implemented was not having it.
uh,
Like most of the methods we need to generate it.
Yeah,
yeah,
Raj, so regarding that adders, so it's good to remove those, and you can go ahead and remove those because we don't need them. And to add here in custom monitor factory, uh, you have this param in the comments cluster object. I think you can get rid of obj part, just leave it as cluster.
okay.
Yeah, thank you.
And I think that's it about this custom monitor refactoring. If you have any questions, you can ask now regarding this
Raj,
cluster.
one feedback on the variable naming. I saw some maps like that you have declared. I can't exactly remember the class, so it's better if we can like name the map name so that it gives us a clue what the map is about. Say if the map is like uh, the key is cluster ID and then the value is cluster monitor or anything, you can like use a name like cluster monitor to cluster ID to monitor or something to like reflect that, so it will be easier to spot when you are reading the code.
So you are talking about this map, cluster monitor.
Ah yes, this is one place. Yes.
Yeah. So cluster monitor cluster. How you want this be?
Like it's my opinion that if we can rename this like to cluster ID to monitor or something,
Uh,
it will be easier when we are reading the code because this will be referred in other places. Always we will need to come to here to figure out what is the key that we are used here.
yeah.
Yeah, so I agree with that point as well. If you look at the other code in some of the components, we have used that pattern to name the variables.
Okay.
And Raj, in the factory, why do we have static methods?
Mm, this method.
Yeah, why it is static? Do we need to be? Do we need it to be static?
Yeah, because when we are used in my
Oh,
I think
it's not an inst. You
yeah,
don't
when we are using factory,
instantiate.
we don't create an instance for factory, right? We are
Oh
just
yeah, yeah. Sorry. Yeah, got it. And if we go to abstract cluster monitor,
okay.
okay,
Yeah, this is abstract cluster monitor.
yeah, yeah. Can you scroll down? this. I can't find the place that I noticed. Yeah, that's fine. I can't find the place I noticed something.
And are you using like so many arguments in I saw like one of your monitor was using so many arguments, but that's not this one.
For
I can miss it. I can't exactly remember what's that monitor.
the constructor,
Yeah, constructor was using so many arguments.
if we need this argument, class file, service ID, deployment policy, auto scale policy.
Okay, maybe this one, this super. Whoa, how many arguments it is using?
4,
Is it 6?
4, right?
No, the super VM cluster monitor. When you are calling super.
Yeah, 6. Because here we are
No,
just
it's 8,
passing
right?
the.
No, can you go to your cluster monitor?
4, 5, 6, 7. Yeah, we have 7 arguments.
7, right? But I'm also not exactly sure how many arguments we can use, but as I can remember, there's a convention to use like 6 or 8 arguments in a method. Otherwise, we have to split it somehow, or like pass some kind of like you need to create a class and then pass a reference or something like that. Maybe uh,
Yeah,
maybe
I
we
think.
can check on that and
Yeah, I think we need to wrap those arguments using an object or something. It's even I think 4 is the maximum probably,
okay.
as I feel. So
Okay.
Maybe we can check on that and update our documentation so that we all will follow that up.
And Lahiru, I have one question about this autoscaler rule evaluator.
Yeah.
Here we have defined this rule files as a final string variable,
Yeah.
and then we are loading this, right? So now we are going to have different rules file for Docker scenario. If
Yeah.
so, can we make this 3 as parameter for this constructor and load the files accordingly? Then only we can load different files, right?
Sorry, I didn't get you. Do you mean you need to change the if you need to change the name or something, then you can pass the variable?
No. What I'm meaning is we had to ask this 3 as a parameter for this class. Like in the constructor, when you are creating a autoscaler rule evaluate object, we are passing these 3 files. 3
Okay,
file
what's
names.
okay? What's the benefit?
Then each Docker cluster monitor can load different rule files. Otherwise, now it's one, right?
Okay.
So, for example, if I go to here, I'm just passing the autoscale rule evaluator right here. So
Yeah.
it will load the default file.
Ah, right, right, right. You mean the every time we pass it, it will load all 3 files, right? That's the. Is
Mm,
that the? Yes. Sorry.
what I mean is now for every type of cluster monitor, we are passing we we are creating new autoscaler rule evaluator, right?
I see. So
But it is
you
going to
mean
load the same file. So we should
uh,
make this as an argument, then only we can load the different files.
yeah, yeah. Okay, I got it. So with the introduction of Docker
Yeah, yeah,
rules file. Okay, okay, that's correct. Do that.
yeah.
Yeah, that's correct.
So if you have any questions regarding this,
I have concern on the name. So I think we are following Kubernetes cluster as the convention now, right?
mm,
Yeah, I think we had the thread, and it seems we are married to Kubernetes name, and so here we thought of using Docker since it is a Docker cluster. I think we should rename it to Kubernetes if we are going to stick with that, or change to Docker
I
everywhere.
think Akhil, we have agreed to Docker name, right? So Kubernetes cluster.
Um, Here the thing is, we are not going to monitor the Kubernetes stuff, because Kubernetes is itself a manager. It is responsible for maintaining those Kubernetes pods and all. So I think it should be named as Docker.
Yeah, that's what I also thought. I think Nirmal should.
Yeah,
Uh,
so if you look at the container cluster monitor, currently you have Kubernetes cluster context, right?
yeah,
Yeah.
So how would you relate those two? How would you relate Docker and Kubernetes cluster context? Why, if it's a Docker thing, why you would keep a Kubernetes cluster context? That's my point.
so do we have like a lot of Kubernetes specific variables there,
Uh, yeah,
Nirmal?
replicas.
So that code, I don't familiar with. So Raj have to answer that.
All right.
Yeah, this min replicas and max replicas.
Yes, yeah. So I'm not suggesting it to name as like Kubernetes cluster monitor, but it can be like, so what we monitor is the Kubernetes entities. It's not the Docker what we monitor.
Okay.
So what we monitor is the Kubernetes pods, Kubernetes replication controllers, and stuff like that. Kubernetes services, service proxies.
Yeah. So
So
that
it's not
means
the direct Docker
yeah,
instances. Yeah.
I also agree. So then I think we should go ahead and change the Docker cluster monitor as well, because we should uh, keep the same, right?
Yeah, okay.
Yeah. So can we like replace Kubernetes with new software and use the same logic in the future?
I don't think so, since we have already embedded the concepts of Kubernetes, the number of replicas and the Raj, can you go to the Kubernetes cluster context? What else we have there?
It's not completed, but
Yeah, it's not completed. And Kubernetes cluster ID. So if there's some other Docker management tool or something like that,
Yeah.
so we have no idea whether it has this concept of cluster.
Okay. I think even if
Like,
we get new one, we can change the names in the future. So let's go ahead and change everything to Kubernetes.
yes,
Otherwise,
so
we
I think
don't
if
need
we
to
if
do
we
it.
get a new one,
Yeah.
we have the hierarchy now, right? So we can easily extend the abstract monitor and create a new monitor, right?
yeah.
Since it's a new
Yeah.
implementation, what we gonna support.
Yeah.
This is my
Those are
idea. I'm
again.
not sure, so uh, we have to. I'm not good at names, so I
Yeah.
don't know.
Yeah, so yeah, then it's fine. We can just decide that in the future. Yeah, we
Yeah,
can change.
Nirmal, my point is that in this Docker cluster monitor, sorry, Docker service cluster monitor, are we, so if we rename that to Kubernetes service cluster monitor, are we really monitoring Kubernetes stuff? Are we really communicating with the Kubernetes API and checking whether the Kubernetes pods are working correctly. No, right? We are taking those, we are monitoring through in a separate mechanism using cartridge agent health stats, right? So that's why I had that concern whether we should really rename that to Kubernetes Service Cluster Manager.
So we monitor the we get the health stats from the CEP, right? And then what we so what we really do is create in the replication controllers or expand in the replication controllers. Cluster monitor. So
Yeah,
I
I
don't
guess
know.
for now we will just stick Kubernetes
Yeah,
Service
let's
Cluster.
discuss in the thread. I think that's better.
Yeah, so anyway, we have to stick with one thing because we are talking about one thing at both places. So it would be clear. So it would be Docker Kubernetes should be one. For now, Raj, let's rename it to Kubernetes, I think.
Okay.
And also in when registering Kubernetes endpoint, there we have used Kubernetes group, and in notice in this cluster monitor stuff we have used Kubernetes cluster, right? So I think so shall you rename those Kubernetes group references to Kubernetes cluster as well?
Yeah, I think who was the responsible person should talk.
Actually, which part of code do you mean? The Kubernetes host registration code.
Yeah, here in the cluster monitor part, I noticed that the term Kubernetes cluster has been used. Right, Raj? In your
Yeah.
code, you have used Kubernetes cluster, right?
Yeah, I'm using it.
Yeah.
In host registration code, we have used Kubernetes group.
So I think that should be when you press on that host registration code. Let's review that.
Yeah.
Okay, sure.
Okay, yeah. So actually, it seems the group is not a good word. It should be a cluster, I think. Let's see it there. Okay.
Is there any other concern? Or?
And on the Raj, on the very first comments, I guess we mentioned that the we have to initialize the we have to use the complete topology event only once, right?
Yeah.
So I just refreshed myself on that code, and seems what we expected to do is so we in each of the components, say for an example the Stratos manager,
Yeah.
you could keep a topology model by your own, Stratos manager component can keep its own topology model.
Okay.
And in addition to that, we have this generic topology as well. So what Stratos manager uses these events for is to build its own topology model.
Yeah.
Okay. And so what we do at by listening to these events is just to build this model, build this Stratos managers model. So we first listen to the complete topology event, and then build the initial Stratos managers topology model, and then set it to initialized. So we have initialized the model of the Stratos manager, right?
Yeah.
And then if it is already initialized, we would not execute this complete topology event.
Okay.
And then after that, after that particular point, we would listen to other events and then build up the remaining part of the Stratos manager's topology. So that's the kind of structure we have followed thus far. And in the autoscaler side, as far as I see, we don't maintain a topology model, inside the autoscaler component, but we use the generate topology model, right? So I think that's the reason that there's kind of no way to terminate the complete topology event listener after listening only once. So that's why it is getting executed every time. But since we have that particular check where when a cluster monitor when a cluster monitor is already created, we are not going to create it again, right? So
Yeah.
as far as I see, I don't see any issue with that particular code. Maybe others has different views on that.
Yeah, even if this is executed every time, it is doing nothing because inside this method we have a checking whether the monitor is there or not.
But Raj, there's an two-level iterations before that, right? I think that's unnecessary.
Yeah.
But Akila, this is I think this is a new thread, right? Really?
Nirmal, even we are make a instance instant variable. Even we are listen to the topology, no, complete.
Sorry, Gayana, can you repeat that question?
The regarding the complete topology event listener, even we are making the boolean to initiate the if it is initiate or not. Even we are listen to that topology listener, no.
Oh yeah, there's if you register the event listener, there's we can we are inside the
We have to listen, but we have to skip if it is initial.
yeah, when you listen once, you are inside the event, right? Since then only way is some other thread would detect and terminate the listener or unregister the listener, but
Yeah.
currently we don't have such a mechanism.
Yeah,
I
yeah. I think we don't need to unregister the listener. We just listen and we can skip if it is not needed.
Yeah, this is running on separate thread, I guess.
Yeah.
This is a event listener.
Yeah.
I'm not sure if I get the idea. Last time we discussed this. So in the topology class, we have isInitialize method, and we have a topology object for each component like autoscaler, Stratos manager, right? So
For your issue, Lahiru, if Raj could open up the complete topology event processor, you will be able to see it. There is initialized and
Hi, can you hear me? Hi, can you hear me?
Yeah, we can hear you.
yes,
I
we
think
can.
I dropped out because my network connection is not good. So what I was saying was,
Yes, Lahiru, as
yeah,
you could see here,
yeah,
it's a topology is not initialized. We are initializing it and then updating the in-memory topology model. But
yeah,
if the topology is already initialized,
yeah.
then we are notifying the listeners. So regardless of the initialization, we are notifying the listeners. So that's the model, because if you go,
You mean that complete topology Event listener will be triggered when it is initialized.
Uh,
No, no, it is initialized every time. Sorry, it is triggered every time.
every time, yes.
Yeah.
So after this if block, there's a notify listeners. Raj, can you find out the
Okay.
end of this if not properly initialized block? And if you go to that, yeah. So after that, we are notifying the listeners, which means regardless of the initialization, we are notifying the listeners. But that's okay because that's the purpose we are having the listeners, right? So even though some other party might interested in each of the complete topology events, we
Okay.
cannot
I see.
restrict this. But at the subscriber level, they will have to do whatever they want. Like whether they want to do it at the first time and get rid of it, or like each of the time they are going to do. That's up to them. This
Yes. Okay.
this
I
is what
think.
I understood.
So it's initialize this.
Yes, so what happens is like, so someone generates the complete topology event, right?
Yeah.
And then it publishes the complete topology event to the message broker. So then we have this like, in the messaging component, we have these message processors. In this case, we have this complete topology message processor in the message processor chain. Then it would get executed, and then it would build the generic topology model. So that is the topology model that is available for all the components which are used in Stratos basically. And so you can't guarantee that when it comes to the events, when it comes to the event listener, that the topology is not initialized
Yeah.
even at the
So
very first time,
yeah, I
because
think.
the generic topology is already initialized.
Yeah. Correct.
It
Correct.
can be initialized.
Yeah, so I think as Nirmal mentioned, then we have to maintain the state inside a component, but we don't have to build the topology for that, right? We just have to have one variable or something, right?
Yeah, so in the autoscaler case, autoscaler, as far as I know, autoscaler doesn't maintain its own topology, right? So
Yeah, it's just the
then
variable topology variable.
yeah, then it just listens to the complete topology, but it should ideally execute it when it is necessary. So
Yeah.
in this case, I think this code is fine. It would execute forever, like for the lifetime of the autoscaler, but it would not create multiple cluster monitors, right?
Yeah, because it's not possible, right?
Yeah, since we have a check, so
Yeah,
that's how
I
we
think.
control the
Yeah. I think we can do it better by adding a variable to autoscaler context, can't we? Just add the variable in autoscaler context and have whether it's yeah, the cluster monitors are considered for the new topology or not.
Yeah, we can do that as well.
Yeah, I
And
think that's the better thing. Otherwise, it's just at
yeah,
least a single
i-
line processing every time.
yeah, if recursing through the cluster is a problem, then we can do.
Yeah, I think that's better. It's at least saving one line of efficiency.
But like to even then we have to mention what is the now we know the what the cluster is complete topology event is published, but we have to publish with the cluster ID, no?
No, the complete topology event means it has all the clusters. At the first time, we don't have those clusters in our autoscaler context in the maps. So that's why we add those cluster monitors at the first time, initialize those.
Yeah,
So this is just one time for all the clusters.
yeah, one time. Yeah, then we have to change the event, no? Because if it is cluster, it will be cluster wise then. If we change with the auto scaler, the can't be the same event for the every cluster.
No, Gayan, the I what I mean is in the complete topology event,
Yeah.
it should contain all the clusters at the moment. So what we just have to do is add cluster monitors for all the clusters which we have inside that complete topology. So this is one time we just need to add cluster monitors. What we are doing, it seems, we are trying to add all the cluster monitors all the time we get the complete topology. So
Yeah.
that's what we are going to avoid.
Lahiru,
Yeah.
on the cluster created event, we are creating cluster monitors and adding, right?
Yeah, that's correct, because that's cluster wise.
Yeah, then why we are, so what we are doing here?
So
Raj, that
guys,
is to
yeah.
Okay, wait. Topology manager.
Raj, that is to initialize the cluster monitors at the first time, because if let's say there are clusters created already and autoscaler gets restarted, then it will not have that information, right? It will not get cluster created events for those already existing clusters.
Yeah.
So we have to first initialize from the topology, complete topology event published by the CC. Then after that only we have to listen to individual events and build up the model.
Yeah,
So
at cluster created event, we just have to add that particular cluster. So yeah,
Yeah.
Nirmal, go ahead.
No, I have nothing. So
Ah,
Akil explained it correctly. So I think we should stop the hangout now. It's
yeah.
like almost 1.5.
Okay, thank you everyone for joining this hangout.
Thank you, Raj.
And thanks very much, Raj, for the informative session.